you're getting your test on Monday, and it'll be the usual one, and it'll take the usual format as it did last time. So there's nothing really more I need to say right now. Okay. Here we are looking at the three main trig substitutions, as I call them, x subs. If it's a number, take away x squared, use a sine theta. If it's an x squared, take away a number, use a secant theta. If it's an x squared plus a number, or a number plus x squared, because they're equivalent, use a tan. And we're going to do these three guys. And if we got enough time at the end of that, I'll talk a little bit about some of the homework. So this is a version of question 7. If you look down at the bottom there, you can see 49 minus x squared. And since that's a number, take away x squared, that's an a sine theta. And good grief. I'm getting distracted by a window. Is there a window blocking the top right-hand corner? Gone now. Okay. Right, and this is the second guy. Yeah, that's better. I don't know what happened there. X squared take away 36 is a 6 secant theta, and this one here is a tangent. I guess technically it's 1 times tangent theta, but you would just really say tangent theta. So get these guys out of the way. Bring back our sheet with all the identities, because there's a good chance we're going to use some of them. Right. So there's the first one. So you differentiate with respect to theta, and you get 7 cosine thetas. You do the crossover, and you now have dx. So this fella is now going to have all the x's turned into thetas. So x squared becomes this guy squared. On the bottom, the square root of 49 take away x squared becomes 49 take away 7 theta, 7 theta, e squared. And the dx becomes 7 cosine theta, d theta. Okay. If you get an integral like this, are you comfortable about knowing which x sub it should be? Once you've got the x sub, you should be able to do the process of getting dx. Once you know this guy, turn everybody into thetas. Then what we do is style points. We start playing about with things. So that's 49 sine squared theta times another 7 times cosine theta d theta. And on the bottom, square root 49 take away 49 sine squared theta. Now, if you've chosen the right one of these, the guy that's in the square root should actually simplify a lot. In fact, the square root should disappear. And you know, I shouldn't have called that 49. I should have called it 7 squared. So I'm going to pretend it's 7 squared. So that way I've got 7 cubed sine squared theta, cosine theta on the top. This guy here is going to be 49, 1 minus sine squared. Okay, so I was saying the guy inside the square root should become really nice. You pull out a 49 as a common factor is that guy. But what is 1 minus sine squared? What can I replace it by?
Cosine squared.
And won't 49 cosine squared play well inside the square root? And you'll get 7 cosines. So we now have 7 cubed, 7 sine squared cosines over 7 cosines. There. Cancel out some 7s, cancel out some cosines, and you are left with 49 sine squared theas. Right, we've seen that happen before. When you get to the integral that has sines in it, in this case sine squared theta, your next stage is either going to be a U sub or a trig identity. Depends on what you've got here. Would you agree in this case it's going to be a trig identity? So we have to find another version of sine squared. So I'm going to pull out the 49 at the side here. What can we rewrite sine squared as that's going to help us to integrate? Somewhere in here, we're going to be able to change a sine squared into something that's more useful to integrate with.
The 1/2 1 minus cosine 2x.
It is, and I'll pull out the half here and just leave the 1 minus cosine guy. And now what we have is 1 gets you theta. And if you integrate a cosine, you get a sine of 2 theta, and you also get a half.
Can you pull the piece of paper up a little bit?
Sure. Yes, short answer, I can do that. There we go. So I'll bring it over to here. So what I've got is 49 halves theta, take away 49 quarters the sine of 2 theta plus c. So we have integrated the question, but what we haven't done yet is return it back to the x's. Now you do, the way that you do that is you return back to the x sub. And you isolate whatever the trig is, in this case sine. And then you go back to your memory on SOHCAHTOA, and you remember that sine is an opposite over a hypotenuse. And from that, you build the right angle triangle. And we'll call this angle theta. And this can be opposite. This will be adjacent. And finally, this will be hypotenuse. And the top is opposite, so the x is opposite. And the bottom is a 7, and the hypotenuse is there. And to get the third one, we use Pythagoras, which is 7 squared take away x squared, and 49 take away x squared is exactly what I wanted to see, because it matches this. Now, what you then can do is that this triangle will allow us to turn any trig expression here into x's. Now, the guy I need is I need to know him. Oh, what about the 49 quarters later? Would you agree that we need to use an identity that uses sines and cosines to get this guy? And hopefully you remember the double angle, which is sine theta, cosine theta. That's 2 times. The sine of theta is opposite over hypotenuse. The cosine of theta is adjacent. Over hypotenuse. So this thing becomes 2 49ths and x, a square root of 49 minus x squared. So we now know how to convert just the sine of 2 theta. Now in this other one, we have another guy. We just have a theta. Sometimes you get a theta. I've seen theta squares as well. If you notice this line here, that sine of theta is x over 7, I can tell you that theta then is going to be the inverse sine of x over 7. So that's how you get the theta. I don't really need the triangle for that, but there it is. So our answer to the original question, which was this fella, is going to be 49 over 2 theta, and that's what theta is. So 49 over 2, the inverse sine of x over 7. Take away 49 over 4, this guy. Just a tiny bit of tidying up and we're finished. 49 cancels, that partially cancels, so I'm left with a half. We are done. And that's the first one of the 3 today. Any questions about that process? We managed to follow it? Are we good? Put that one to bed then. It's the second one of the 3. Okay, this one has an x squared take away 36. When you see it that way, you're using 6 secant theta. So if you differentiate with respect to theta, what do you get if you differentiate a secant?
Secant theta, tangent theta.
Agreed. So I'll stick a 6 in front of that. When you do the crossover, it's that bit done. So we now take the original and we turn everybody into thetas. So x squared take away 36 is going to be, let's do that in my head, it's going to be 36 secant squareds take away 36. And x to the 4 is just going to be 6 to the 4 secant to the 4th power. And the dx is going to be a 6 secant tan. Whoa, just squeeze that in. Now that fella in the square root, if you pull out a common factor of 36, you get that. This 6 can cancel with one of them. This secant can cancel with one of them, so you're just going to have a tangent left here. And on the bottom, you've lost one of your 6s and you've lost one of your secants. Okay, so we can do this guy. Secant squared minus 1 is going to be something. It's going to be something nice, and it's going to play well inside the square root. What is secant squared minus 1? Secant squared. Say again?
Tangent squared.
It is. So that gets me 6 tangents. That 6 will cancel with one of these. So now I've basically just got 36 in the bottom, so I'll pull it out. and I've got a secant cubed, and I have a tan squared, and I have a d theta. You happy about this? I've done kind of 2 lines in one here. That 6 cancels with that to gives you 6 squared. So that's the 1/36 I filled out. That's a tan, joins this one, there's a square, and that secant cube still there. That says secant cubed on the bottom. Okay, we got a problem with now this fella. We need to integrate 1/36, the integral of tan squared theta over secant cubed theta, d theta. And it's going to be one of 2 things. It's going to be one of 2 situations. It's either going to be a u sub, and if it is, it will be secant theta or tan theta, or we are going to use identities to turn this into something else. Any suggestions?
It looks like a U sub.
Okay, could well be, might not, but it could well be. If it was going to be a u sub, what would be your gut feeling for which one you would use? Not obvious, is it?
No.
But it's a good thought process. It just doesn't work. The sine, the secant or a tangent, if you try it out, you never quite get rid of the other guy, right? There's always going to be some orphan that you just can't figure out, how to get rid of it. Now, if it had been secant cubed times tan squared, I bet you that would have been a u sub. But fractions don't always behave the same way as the same 2 terms multiplied. So let's work on, if I can't do it with a u sub, then I'm going to have to turn it into some other stuff, right? What can you turn tan squared into, and what could you turn secant cubed into? And what I'm getting at here is, one of the strategies for something that's really weird is to just turn everybody into sines and cosines. Sines and cosines tend to play well together. So I'm going to take the tangent, and I'm going to call it sine squared over cos squared. You all happy about that? And secant cubed, I'm going to call that 1/cos cubed. So I'm going to make this thing uglier before I make it nicer. If you've got a fraction divided by a fraction, can't you convert it into a top fraction multiplied by the reciprocal of the other fraction? Are you happy about algebraically what I just did there? Tan squared, secant cubed. Tan squared times the reciprocal of the bottom. Now, there's some cancelling going on here. And what we are left with is sine squared theta, cosine theta, d theta. So this guy, which we couldn't do, has now been turned into this guy. What do you think about this guy? Do you think this is a good candidate for a u sub? Yeah, don't sines and cosines play really well together, right? As far as u subs go. So tell me who the u sub is.
Sine.
Agreed. So du by d theta is a cosine. And then we do our crossover. And then we divide both sides by cosine of theta. And what we've got is a way to turn everything here now into u's. So we've got 1/36 u squared cosine of theta, 1 over the cosine of theta, d theta. And you should be amazed at how pretty, so that's a u, how pretty the answer is. Would you agree that is a really pretty answer? Just a u squared. Now I can integrate that, and what do I get? I get add 1 to the power and divide by the new power. And we got that. Are we good? Last phase is our triangle. We're going to take this and turn it back into the x's. So, oops, I forgot to do that part. 1 over 8 sine cube theta plus c, right? So we're going to use x equals 6 secant theta. And that guy is going to generate our triangle. So it's going to be x over 6 is secant theta. Now a cosine is adjacent over hypotenuse, so a secant will be the reverse of that, a hypotenuse over an adjacent. Then I'll build my triangle now. I have an opposite, I have an adjacent, and I have hypotenuse. The hypotenuse is x, the adjacent is 6, and by Pythagoras, this guy is x squared. Take away 36, and I look at my original, and things are looking good. Agreed? Well, I need to know what sine theta is so I can cube it. Well, the sine of theta is the opposite over the hypotenuse. Forget the cube. The sine of theta is this guy over this guy. And so our answer is this fella, sine cubed theta plus c, which will become this fella cubed over x cubed plus c. And there's the second one done. These questions are quite convoluted, right? They're quite lengthy and they take funny little turns. And not every question is not quite the same as every other one. I mean, for instance, in this one, wasn't there a kind of change in strategy where this didn't work as a u sub and we had to do this, turn everybody into sines and cosines? Maybe the next time this guy will just be sine theta. It'd be great if it was, wouldn't that be a dead easy one? But maybe it'll be tan squared secant cubed, in which case it'll be a u sub, right? You just don't know what you're going to get until you find this expression. And if it comes out easy, then you say thank you. And if it doesn't, you have to find ways to solve it. Anything about that second one? Are we good? I'm looking at pictures, but I can't see any sad faces. I can see Ismail looks like you just get run over by a bus, look. Okay, last one in the set. Because basically what I've done today is pretty obvious what I've done. I've given you one example, or I will have when this is finished, of each of the 3 major types. So anything that comes after that is going to be one of those 3 guys, right? It's going to look in at least some ways similar. So this is the final one, and x is tan theta. So if you differentiate a tangent, you get secant squared theta. And if you do a crossover, you're finished. So this fella here, I'll write him down here. is now going to get turned into thetas. So it's going to be the integral tan cube theta square root of 1 plus tan squared theta, followed by a secant squared theta d theta. What is 1 plus tan squared going to get me?
Secant squared.
Correct. And so won't the square root of secant squared just be secant? And I've kind of combined a couple of lines of work in here, but are you happy how the secant squared is now a secant cubed? Right, that's secant squared, the square root of a secant squared is a secant, join it to this one, and now you've got 3. So we're looking at this guy, aren't we? Write him down over here. So where are we off to now? I don't hear any responses. What should I do next?
Can you use the U sub?
Okay, seems like a good idea. Any suggestions for what that U sub might look like?
Wouldn't it be tangent theta?
Okay, what do you get when you differentiate a tangent with respect to theta? And this is what you're going to do, so I don't want to just say yes and no. So let's work our way through this and see if it's a good. What's tangent theta going to get?
Secant squared.
Going to get me secant squared. When I do my crossover, I'm going to have secant squared theta d theta. So far, so good. Great. What's going to happen now? Can you see that we're going to have a secant left over? I don't mind secant squares left over, right? Squaresy things left over is good news. We can deal with them. Isn't a sign left over that you don't want, or a secant left over, or for that matter, anybody left over, right? A single left over. Isn't that bad news? So what I would say is I tried it and it didn't work. But the good news is, since there's only 2 choices, I now know the right one to use. I won't call that that's not a bad strategy. I know there are going to be lots of examples where I will look at them and I won't know, because I haven't quite seen this particular combination before, I won't know who the U sub is. Now, you might say, well, what happens if I do both U subs and both of them, fall apart, right? They don't work. Well, that's because I shouldn't have been doing a U sub. Shouldn't I be turning everybody into sines and cosines and go that route? And we'll assume that the questions are doable, because there are a lot of trick questions you can't get the answer to, right? So if we make the assumption it's doable, right? There is an answer that you can get. It's going to be U equals secant theta, U equals tan theta, or turn everybody into sines and cosines and do what you can. I guess there is a fourth one I just thought of. Can you maybe do some kind of trig identity and change it into something nicer? Right, you could do that as well. So we're going to do a secant theta. And that guy is going to give us secant theta tan theta. And we do our crossover. Nothing particularly amazing happened. Let's put it down here. It's a tan cubed, a secant cubed d theta. And it's going to be tan cubed, secant cubed, this guy. And that's a U. So what have I got? Okay, I have a lot of horrible guys left over, but guess what? Aren't they all nice even powers? We can handle even powers. There's the secant taken care of. Can someone tell me a version of tan squared, that has secants in it?
Can I
Secant
ask a
squared minus
question?
1.
Right, this one here. Agreed. Right, a version of tan that has secant squared. So isn't this essentially tan squared theta squared? Which means it's 1 minus secant squared squared. Which means that it's 1 take away u squared squared. Right? I mean, you had to fight that one, right? But it worked. What do I do next? Yeah, I want to integrate this, but what do I have to do to be able to integrate it?
I have a silly question.
Yes.
Where did the DU come from?
Thank you.
Where did you substitute DU?
Oh,
Okay.
don't know. I mean, it's there. Well, it's there. And then it kind of
Doesn't
gets
that mean it
crushed.
should be 1 over secant tangent?
Say it again.
Wouldn't that mean it should be 1 over secant tangent?
D 1 over secant tangent. Was that? Thank you. Right. Pretend the last 5 minutes didn't happen. We decided that secant is going to work and that du by d theta is secant theta tan theta. That's okay. And that du is secant theta tangent theta d theta. And then I forgot to do this line. Actually, that might make our question a little bit easier. We shall see. Okay. So let's return. We have a tangent cube, still tangent cube, still secant. This guy is now where the du comes from. Right, and that du should be there. Secant tan. So I'm now looking at tan squared, secant squared du. Remember, our goal is to get use. So it's going to be tan squared times u squared, right? It's not that dissimilar. And isn't a tan squared a 1 minus a secant squared? So that's the same basic math, but with a nicer power. And so it's 1 take away u squared du. Okay, we fixed it. Right, what's going to happen next?
Distributed.
And then power rule, right? So it's going to be u squared, take away u to the 4. Power rule. Power rule. And that becomes 1/3 secant cubed, take away 1 for 1/5 secant to the 5th power, I'd say. Okay, we good with that? After a little hiccup, we good? One of the annoying things about these questions are there are lots of little places where you can screw up. And so you can do 90% of the process and still not get the right answer. Good news is that in a test, you only lose some points. If you did say that mistake I did, it wouldn't be a total disaster. So we are now on the final stage. This is the answer in terms of secant theta, but we want the answer to be in terms of x's. Trying to find my original question here. I've lost my original. What was the guy called when he started life here? He was called, here we are, so we're here. We went and used tan theta, and that was the original question. Okay. Now we call it x over 1. And we know a tangent is an opposite over an adjacent. And so we can now build our triangle. Put the angle theta here. This is going to be opposite. This is going to be adjacent. And this is going to be hypotenuse. And so the opposite is x. The adjacent is 1. And by Pythagoras, this guy is the square root of 1 plus x squared, which is good. I need to know what a secant is. Well, a secant is 1 over a cosine. So instead of adjacent over hypotenuse, it's going to be a hypotenuse over the adjacent. And the hypotenuse is this guy. And the adjacent is that guy, which means that it's simply just that guy. And so our answer to the original question, which was this fella, is 1/3 secant cubed. So it's going to be that guy cubed. Take away 1/5 secant to the 5. I'd say. And we now finished. We had a little hiccup towards the end, but kind of pulled back. Are we good with that question? So they basically averaged 15 minutes, and I wasn't really stopping for much there. So you know you're going to have a fair amount of work to do on those questions. So for the last few minutes, let's see if we can look at what is going to be involved in your test. So got some windows I don't really want, put that there. Okay, give me a few seconds just to load up Canvas. Okay, this one should be here. That over there. Right. Well, it's going to take your test. It's going to take the same basic format as before. WebAssign will disappear. That didn't work. WebAssign will disappear. Canvas, all the videos and so on will disappear. And so you're only, basically, you'll have a PDF in Canvas that you'll be able to see. And Desmos will be there, you know, if you need to see a picture of it. And you should be looking at our syllabus here. So let's just remind you where we started and where we finished. So you are going to be getting a question on cylindrical cells, shells. Remember the 2 pi x f of x thing, right? Those guys, volumes of revolution. What, you remember the questions to do with springs and pulling buckets of water that had leaks in them? I think the average value of the function is pretty straightforward. You could do that one's pretty much plug and jug, nothing too strange. Integration by parts, right? And last but not least, trig integrals and trig substitution. But the trig integral and the trig substitution, I've decided to make one question. Because in trig substitution, x subs, don't you very often have to do a trig substitution in it to get the answer? So I'm kind of asking both things. So what that means is that you're essentially going to get 1, 2, 3, 4, 5 questions. 1 cylindrical shell, 1 work, 1 average, 1 integration by parts, and your last question is going to be one of those big ones. But that big question I just did take 15 minutes, right? But that's the biggest question you're ever going to do. All the other questions will take a lot less time than that. So I feel comfortable that you're not going to be overloaded with time, right? You'll have enough time to do it. I'm making this up, but I bet you the average value of a function question probably takes 5 minutes, right? They're pretty straightforward. Right, any questions?